Every morning, millions of people around the world begin their day with the same ritual. A little toothpaste, a toothbrush, and a few minutes in front of the mirror. But have you ever wondered what's behind that little tube? How is Colgate toothpaste, one of the most recognized brands on the planet, really made? What you're about to discover will surprise you. From tons of rock transformed into a smooth cream, to an industrial process that blends chemical precision with robotic speed, toothpaste production is far more complex and fascinating than you might imagine. What role does the underground water play? How do they ensure each tube contains the perfect amount of paste? And how do they keep the colored stripes from mixing? In this video, we'll go deep inside the Colgate factory to follow the complete journey of a product we take for granted, but which is the result of centuries of innovation, science, and industrial design. Stay tuned until the end, because each step hides a surprising detail about the making of Colgate toothpaste that you probably wouldn't believe. The Colgate story begins in 1806 in New York City, when William Colgate, a British immigrant, founded a small business dedicated to making soaps and candles. No one imagined that this modest enterprise would become one of the world's most iconic brands in the field of oral hygiene. For decades, the company expanded its product range, but it wasn't until 1873 that it introduced its first toothpaste, a revolutionary product for its time. Unlike the homemade mixtures many used at the time, this toothpaste was scientifically formulated to clean teeth and freshen wool. Initially sold in glass jars, everything changed in 1896, when Colgate first launched toothpaste in a tube, an innovation that transformed personal hygiene forever. Colgate's unwavering focus on scientific research has positioned it as a pioneer in the development of fluoride toothpaste, which since the mid-20th century have become an essential tool in the fight against cavities. Over time, Colgate has expanded across the globe. Today, its products are available in more than 200 countries and used by over 2 billion people. The brand represents not only cleanliness, but also trust, health, and technology. This heritage of over 2 centuries reflects not only an evolution of products, but also of values. From sustainability in its factories to investment in oral health education in underserved communities. Before discovering how toothpaste is made step by step, it's worth understanding that behind each tube lies a story of constant innovation, strategic decisions, and an obsession with perfection. Toothpaste may seem like a simple cream, but it's actually a complex blend of science, minerals, and millimeter precision. And yes, one of its most fundamental ingredients comes from an unexpected place: rock. It all starts with mineral abrasives like hydrated silica and calcium carbonate, which are extracted from the earth in the form of stone. These rocks are processed and pulverized into a fine powder which, although invisible to the naked eye, fulfills an essential function. They clean teeth mechanically by rubbing them while brushing. But silica and calcium are not the only components. Humectants like sorbitol and glycerin are also used to help keep the paste moist and creamy. Thickeners such as xanthan gum or carbapol are incorporated to add body and prevent the ingredients from separating. Then come surfactants like sodium lauryl sulfate, responsible for the characteristic foam that helps distribute the ingredients throughout the mouth. Although it may seem chemical, its purpose is purely functional. And of course, we can't forget fluoride. The most important active ingredient. This mineral, present as sodium fluoride or monofluorophosphate, strengthens teeth and prevents cavities, transforming toothpaste into a true protective shield. Flavorings, usually menthol or mint, are added to the mixture to provide that familiar feeling of freshness. Colorings, preservatives, and, in some formulas, natural ingredients such as essential oils or plant extracts are also included. In total, a tube of toothpaste can contain more than 20 different ingredients, all carefully measured and blended with pinpoint accuracy. Because in the world of Colgate, every gram counts. Before we delve deeper into how the famous stripes are created and how each tube is sealed with millimeter precision, has the process surprised you so far? If you enjoy discovering the secrets behind something you use every day, give the video a like and subscribe to the channel, so you won't miss out on any more content that transforms the ordinary into the extraordinary. Now let's move on to the most fascinating part of the process. At this stage, the ingredients are already measured and ready to be transformed into that creamy texture we all recognize as toothpaste. This step is crucial. This is where science and engineering meet to create a perfectly homogeneous mixture. It all begins in gigantic stainless steel tanks, certified according to medical standards. These tanks are equipped with advanced stirring, heating, and cooling systems. Inside, enormous metal blades rotate at different speeds, depending on the viscosity of the formula. The base, composed of humectants such as sorbitol and thickening agents such as xanthan gum, is first mixed with purified water. Next, abrasives are added such as the failed silicide, which gives the paste its cleaning power. Foaming agents, preservatives, pH regulators, and active compounds like fluorine are also incorporated. Everything is added in a precise order and at controlled temperatures. Heat is applied with steam, and cooling is achieved with water at 7 degrees Celsius, circulating through coils. The goal is not to cook the product, but to allow for stable molecular integration. During this mixing process, operators monitor each parameter in real time via a digital console. If the mixture doesn't reach the ideal density, the system adjusts automatically. Once the desired texture, similar to a dense and glossy glaze, is achieved, the homogenizing gel is incorporated. This ingredient ensures that all the components remain perfectly distributed and gives the dough its firm, yet soft-to-the-touch consistency. What's surprising is that this process, which can move up to 5 tons of mixture in just a few minutes, is completely automated and airtight. No step is left to chance. The goal? To create a perfect base, free of lumps and imperfections, ready to take it to the next level of refinement and quality. The basic toothpaste mixture is now ready, but one crucial step remains before it can be packaged: removing the air trapped in the formula. This process is known as degassing and is one of the keys to achieving the perfect texture. During mixing, small air bubbles become trapped in the paste. If these bubbles are not removed, they can cause inconsistencies, affect the final appearance of the product, and even reduce its shelf life. To solve this problem, the mixture is passed through an industrial vacuum system. Inside enormous airtight tanks, the paste is subjected to negative pressure. At first glance, the mixture appears to boil, but in reality, the vacuum forces the air out. This process also helps to ensure a smoother, more uniform texture that is easier to dispense from the tube. Once degassing is complete, one of the most important departments in the entire plant comes into play: the quality control laboratory. Here, specialized technicians take random samples from each batch and perform physical, chemical, and sensory tests. Parameters such as viscosity, color, odor, density, and homogeneity are evaluated. We even test the taste to ensure the end-user experience meets our standards. If any of these parameters fall outside the acceptable range, the entire batch is rejected or reformulated. This control system guarantees not only product safety but also its effectiveness and shelf life. Only once the laboratory approves the sample can the mixture proceed to packaging. With the mixture degassed, inspected, and approved comes one of the most fascinating stages of the entire process: the creation of the stripes. Now that the mixture is ready and approved, one of the most intriguing steps of the process begins: the creation of the famous colored stripes. How is it possible for the red, blue, or green to remain perfectly separate inside the tube without mixing with the white paste? It all starts with a separation system. The already refined paste is separated in large vats according to the color to be applied. The white base goes to one side, while the same mixture, to which safe and approved oral colorants have been added, is channeled to the other. The secret to keeping the stripes intact lies not in a physical barrier, but in the viscosity of the paste. Each color is injected through separate nozzles in the same tube via a filling head that allows for absolute precision. Because the paste is sufficiently dense, the colors do not mix. When the user squeezes the tube, the pressure causes the colors to come out simultaneously in the same direction, creating the appearance of stripes. This design is not only visually appealing, but it also serves an emotional function. Consumers associate stripes with freshness, technology, and advanced cleaning. Although the stripes don't contain any different active ingredients than the rest of the pasta, they play a significant role in product perception. Furthermore, marketing studies have shown that consumers prefer striped pasta to pasta of a uniform color, even if both have the same formula. In short, the mystery of the stripes is an achievement of precision engineering, combined with a deep understanding of fluid behavior, visual aesthetics, and consumer psychology. After successfully navigating all the phases of mixing, quality control, and final design comes one of the most meticulous moments in the process: packaging. Here, Colgate toothpaste is ready to be poured into the tubes that will reach millions of homes worldwide. The process begins when empty tubes, manufactured on a separate production line, are lined up and transported on conveyor belts to the filling stations. These machines operate at astonishing speeds, filling up to 180 tubes per minute with an exact precision of 100 grams per unit. There is no margin for error. The product's viscosity allows the strips to remain intact during filling, creating that characteristic visual effect. Once filled, the tubes are heat-sealed using controlled heat, a crucial step to ensure product hygiene, maintain freshness, and prevent leaks. After sealing, a robotic system rotates the tubes to perfectly align the graphic design before they move onto the conveyor belt. Before proceeding to the next stage, random samples are taken for physical and visual analysis. We check that the contents are uniform, that the stripes are well defined, and that there are no excess tubes. If everything is in order, the tubes are grouped into packs of 15, then placed in cartons containing 24 units. These cartons then pass through a high-precision automated weighing system. If it doesn't reach the ideal weight, it is removed immediately. Only cartons that meet the strictest standards move to the distribution area. Each carton is labeled with key information such as the batch number, manufacturing date, and shipping destination. From there, they travel to supermarkets, pharmacies, convenience stores, and e-commerce platforms in over 230 countries. This global logistics network is one of the most efficient in the world, ensuring that the same tube of Colgate toothpaste reaches a family in Paris, a student in New York, or a grandmother in Australia. And so, what began as rock powder, active ingredients, and aromatic essences completes its journey as one of the most universally loved personal care products on the planet, packaged, sealed, and ready to create millions of smiles around the world. After discovering the complete journey of Colgate toothpaste, from rocks and essence to the perfectly striped tube, it's clear there's nothing simple about this everyday product. Each tube is the result of science, engineering, precision, and decades of innovation. Behind the routine act of brushing your teeth lies a complex industrial process that ensures quality, safety, and freshness with every application. So the next time you squeeze that tube of toothpaste, remember, you're using one of the most refined products in modern industry. And now, a truly troubling question arises. Do you think we use too many highly scientific products for simple tasks that our grandparents did more easily? Share your thoughts in the comments. We want to know what you think. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content. But don't go away just yet. There's more. The rest of this video will be just as exciting, so stay with us until the end.
The pencil is one of the most popular writing instruments ever invented. Worldwide, approximately 20 billion pencils are produced each year, used for drawing, coloring, writing, marking, or sketching ideas. But have you ever wondered how the graphite core is placed inside the pencil? Today, we'll discover how graphite and colored pencils are made, from the graphite core to the finished pencil you hold in your hand. The inner part of pencils, called the leads, is made from graphite. Graphite is a form of mineral carbon whose exploitation began around 1564, when the first deposit was discovered in northern England. It is a natural form of crystalline carbon, one of the softest minerals in existence. When rubbed on paper, it releases tiny particles, leaving a dark, uniform mark. Graphite is found in several regions of the world, in deposits formed by geological processes that took place over millions of years. Modern pencils appeared in 1795, thanks to the French chemist Nicolas Jacques Conte. He had the idea of mixing graphite powder with clay and water, then shaping this paste into thin sticks. These small rods were then encased in wood, giving rise to the first pencil leads enclosed in a wooden sheath. This is how the pencil, as we know it today, was born. Graphite used in mining is extracted either from open-pit quarries or underground mines. It is a relatively rare ore, difficult to locate, and even more difficult to extract and bring to the surface. Miners drill into the rock using specialized tools. They introduce explosives to break up the blocks, or use jackhammers to break up larger pieces and facilitate loading. The ore fragments must contain a sufficiently high percentage of graphite, generally more than 30%, for the operation to be profitable. Once extracted, these blocks are transported to industrial crushers and grinders. There they are crushed, ground, and reduced to a fine dry powder, which becomes the ideal raw material ready to be shipped to pencil manufacturing plants. In the factory, the raw materials used to make the leads have remained virtually unchanged since 1795: graphite, clay, and a little water. The secret lies in the proportions. The more clay you add, the harder and lighter the lead will be. The more graphite you add, the softer and darker the line will be. It's this precise formula that allows us to achieve the different hardness levels you see indicated on pencils, from very hard to very soft. Many people imagine that the leads are made directly inside the pencil, but that's not the case at all. In reality, the leads are produced separately, in long rods, and then inserted between two strips of wood. The manufacturing process is therefore carried out in several distinct stages. To begin, the manufacturers pour powdered graphite, clay, and water into large mixing vats. The machine stirs the paste until a homogeneous consistency is obtained. This mixture is then left to rest for about an hour and a half. This resting time allows the water to distribute evenly, thoroughly hydrating the clay and resulting in a perfectly smooth mixture. For colored pencils, the principle is similar, but colored pigments and a specific binder are added instead of most of the graphite. This binder can be wax or resin-based, giving the or its creamier texture and vibrant color. Once the mixture is ready, it is transferred to an extrusion machine. This extruder compresses the paste under pressure of up to 10 tons through a funnel-shaped die, creating long, thin, perfectly cylindrical rods that will become the ore. At this stage, they already resemble pencil leads, but are still very soft and fragile. To harden them, they are first dried in an oven at approximately 120 degrees Celsius for about 3 hours. This removes excess moisture. Next, in the case of graphite leads, they undergo a much more intense additional firing. They are heated to almost 1000 degrees Celsius for about 40 minutes. This heat treatment transforms their internal structures, making them hard and brittle, which guarantees a clean and precise line. Colored leads, however, cannot withstand such temperatures, as the heat would destroy the pigments and the binder. They therefore undergo only gentle drying. Once baked, graphite leads are dipped in a wax bath. This wax coats the surface, fills the pores, and makes the lead smoother and more durable. The more wax there is, the more easily the lead glides across the paper, and the darker and more even the line can appear. Excess wax is removed in a high-speed centrifugal machine. Upon exiting the mold, the leads have a satin finish and are ready to be encased in wood. Next comes the wood-to-lead assembly phase. For this step, a wood must be chosen that is both soft, for easy machining, and strong enough not to split or warp during use. Cedar wood is considered ideal. It is lightweight, easy to work, and has a pleasant aroma. The wooden blocks used for pencils are generally rectangular, approximately 18 centimeters long, 7 centimeters wide, and 5 millimeters thick. They are first passed through a machine that mills parallel grooves along their entire length. These small grooves will hold the leads. A special glue is then applied to the bottom of each groove. This glue not only provides adhesion, but also keeps the lead perfectly centered to prevent it from shifting when the pencil is sharpened. A metal wheel or an automatic device then places the leads one by one into each groove. A second board, identical to the first, is placed on top. This results in what manufacturers call a sandwich, two well-aligned wooden strips with a row of mines sandwiched between them. These sandwiches are placed in presses and left to dry for about an hour. Under pressure, the glue spreads evenly and the two pieces of wood fuse perfectly together. The result is a block of wood that appears to be a single piece, but which already contains several perfectly positioned leads inside. The next step is to transform these blocks into individual pencils. The blocks of wood pass through automatic milling machines that cut them into the final shape of the pencil, hexagonal, round, or triangular, depending on the desired model. The blades cut the block into strips, then each strip into individual pencils, precisely following the axis of the leads. Depending on the size and model, a single block of wood can yield up to 10 pencils. The resulting raw pencils are still in their natural state, with the bare wood and the lead exposed at each end. They then undergo a preparation stage, inspection, light sanding, and removal of any minor imperfections. The goal is to obtain a perfectly smooth surface, ready to receive the paint. Major brands use water-based paints. These are less harmful to the environment, dry quickly, and do not release toxic solvents, making them safer for school use. Pencils are often painted using immersion or spray systems that ensure a uniform coating along their entire length. The paint is applied in several very thin layers. Depending on the quality and type of pencil, 2 to 8 layers can be applied until a fully opaque, durable, and glossy color is achieved. 1 or more coats of clear varnish are then added. This varnish gives the pencil its glossy appearance, smooth surface, and protects the paint from scratches, impacts, and wear. After painting and varnishing, the pencils go through marking machines. These machines print the brand logo and information such as the model number, color for colored pencils, or hardness, HB, 2B, H, etc., for graphite pencils. The rear end can be dipped in a different color of paint, either for aesthetic reasons, to differentiate certain ranges, or to provide additional protection for the wood. In the final stages, the pencils are sharpened to a point. Machines equipped with rotating abrasive belts sharpen thousands of pencils much faster than any manual sharpener. They shape both the wood and the lead to create a smooth, centered point. Inspectors then visually check the quality of the points, ensuring they are neither too fragile, broken, nor off-center. On some graphite pencil models, a small eraser is also added to the end opposite the point. A metal ring then connects the pencil body to the eraser, mechanically crimped to hold it firmly in place. Finally, the pencils are sorted, counted, and packaged in boxes or cases, then placed in cartons ready to be shipped to schools, offices, craft stores, and stationery shops worldwide. In this way, more than 20 billion pencils are manufactured and distributed across the globe each year. In your opinion, is a mass-produced pencil as valuable as a handcrafted one, or do you think machines will never equal the human hand? Share your thoughts in the comments. We'd love to hear your opinion. If you enjoyed this documentary, please like, subscribe, and turn on notifications so you don't miss any of our content.